Welcome to the afternoon science symposium for the Natural Capital Committee. For those of you with us this morning, we've had our main event and gone through the end of term report from the NCC and what we've tried to achieve and the main points that we've been trying to get over the last 8 years. So this afternoon we're going to home in on the science and we have a packed agenda to go through between now and 4:25. Just to run you through it, Kathy Willis is going to kick off and talk more about data requirements and natural capital, and no doubt developing some of the points that she made earlier this morning. Then we're really pleased to have Rosie Hales with us. Rosie was on the first term of the NCC, and with Georgina Mace drove the science for our first few years in those definitive moments of getting together our methodology. So really pleased to have Rosie now in her National Trust guise. And then we've got Josephine Head from Earthwatch, who've got hands-on experience about citizen science. And this will help to build on a theme of this morning, which was the need for a baseline census of natural capital. So we're going to have those three presentations all live, and then we'll have a break for 15 minutes at 10 to 3 till 3:05 prompt, please. Afterwards, we're going to, after the break, Kathy's going to introduce Chris Collins and Melanie Austin, who were, of course, on the panel this morning, and that will look at the marine and the soil side, the great additional opportunities we've had to look at these issues with Chris and Mel in the second Natural Capital Committee term. And then we're going to have a Q&A, which will be an opportunity to ask questions about all the presentations. So we're not going to have questions after each presentation, but we're going to have questions in that panel session. And then I'm going to close this session, although I feel a bit as an imposter as an economist treading amongst much more impressive scientists. I'm going to try to, in the closing remarks, join up the science and the economics to help explain a bit about the framework we put together in the Natural Capital Committee. So very exciting afternoon. And let me, without taking up any more of your time, hand over to Kathy.
So thank you very much, Dieter. And like this morning, I'm representing the views and the approaches and the discussions we've been having on the Natural Capital Committee over the last 5 years. So I just want to start with the point I made this morning, that the framework that we developed right at the beginning of the second tranche of the Natural Capital Committee was looking at natural capital in the sense of the stocks as a function of the extent and quality, the flows that you get from there, and then the public benefits that result from those ecosystem services or the flows. The other, when we did a assessment, and which was published last week, when in terms of the framework for measuring natural capital stocks, the take-home messages in terms of our current natural capital stocks is that, first of all, we should be focusing on conserving and enhancing natural capital stocks that underpin key ecosystem services, i.e. those that provide this societal benefit. But it's critical that we determine the extent, the condition and trend of these stocks. And when we looked and we did a sort of a overall scoping of the key natural capital assets in the UK and the data sets available, what became very clear is that there's some absolutely critical data gaps that we need to fill, both in terms of spatial resolution, temporal resolution, and also understanding the current condition of our natural capital stocks, be it air, freshwater, biota, land and marine data. We also made the point that the measurement of stocks should be at the systems level, i.e. that we should be looking at drainage basins in particular, or if we're thinking about when we're talking about the flood risks, for example, and a clear recognition that many stocks are in fact location dependent. And this is really critical when we think about biodiversity offsetting and other such policies. What do I mean by that? Well, if you look at the public goods that we get from nature, and then you look at the data input required for those stocks to model the flows, and then ask whether or not they're location dependent, the vast majority of them are. So we look at pollinated crops to start with. Well, pollinated crops, it's obviously dependent on the occurrence of pollinating species, insects, but also the habitats for foraging and nesting. Both of those could be anywhere. But the third thing that often gets missed when we start plotting good areas of pollinators is they have to be near crops that require pollination services. And I have to admit that the number of times I've seen pollinating mixes against fields that are wind pollinated, crops wind pollinated. CO2 sequestration, this is not location dependent, whereas go down that list, flood risk protection again is, as I showed this morning. Clean air, particularly in cities, we need to be thinking about urban trees and tree species and height. All of these things are important. Clean water, again, location dependent, and thriving wildlife sometimes, but not always, because of course a lot of wildlife can actually and does actually move around. Right, so moving on then. Once you have an assessment of the stocks, what additional data considerations are required? And I want to go right the way back to the Lawton report in 2009, which made the point that we need our natural capital assets need to be bigger, better, and more joined up. And then there's the statement in the 25-year plan, which has been mentioned a number of times this morning, which is that we need to leave the environment in a better state than it is at present. And underpinning all of these, what's come through is a number of different policies that are being worked through right now in the pending Environment Bill, and things like the Nature Recovery Networks, the Net Environmental Gain Bill, and the ELMS scheme. So taking all of those together, then, the question and what data and approaches we need is first of all the question, where and what should be enhanced to improve our natural capital stocks once we know where they are, and then where and what natural capital stocks should be joined up. Because it's only by taking those two questions can we really start to properly underpin some of these policies like the ELMS policies, the net biodiversity gain, and the nature recovery networks. So let's start first of all with where and what to join up. So I want to go back to the example I gave this morning, which is the Evenlode catchment in Oxfordshire. And I give this example because it's quite a simple one. And what I showed this morning, through the modelling approaches, you can work out where within that catchment, and this is a drainage basin catchment that feeds directly into Oxford. And if you get storm surges in this catchment, that's when you flood downstream in Oxford. And by modelling the hydrological pattern in this catchment and looking at the soils and the vegetation cover, you can see areas on that landscape in blue, which provide a high reduction in surface water runoff, and areas in red, which act like bare soil. But your question really is, if you're paying money for elms and you want to actually get local landowners to enhance their landscape to reduce flood risk in Oxford, where should you be paying for those elm schemes to take place? And this comes back to, again, thinking a bit more about that drainage basin catchment. And in here, this second slide shows you that if you calculate your travel times through the networks, what you find is the land which is to the northeast of Oxford is much more important to have your elm schemes going on there and pay farmers and landowners to plant trees than going much further west. If you pay to plant trees in the west, they're not going to have much impact on flood risk in Oxford. So it's very, very spatially dependent. But then your next question is, well, how much effect will you have from planting trees? And so again, this comes back to then thinking about the approaches you need to take are very much underpinned by the science, but also starting to set those scenarios. And so in this example, which is work done by Becky Wilbur, she reran the hydrological models, but adding in trees. So she's got at the top left-hand corner, a 5% forest, and then 10% forest, and then 20% forest. So if you changed your land cover, what does that do to your flow down into Oxford? And so when she did this work, what she showed, there are 4 catchments which measure their gauge catchments. They measure the flow coming into Oxford. You've got the Thames at Farnmore, Cherwell at Enslow Mill, Evenlode at Cassington Mill and Rhea Islip. And each of those lines, the darkest blue line is 20% forest. So this is effectively a reduction in discharge if it's below the line. And what you see is with 5%, you get a small amount of reduction. With 10%, you get a greater amount of reduction. And with 20%, you start to get significant reduction in flood risks during storm events if you plant that percentage of trees in the areas that we've shown. So this is then, you've got a much clearer evidence base to be able to go back to those landowners and actually start to pay public money for the public good that those trees are providing in terms of reducing your flood risk. So it's not being top down and then telling people what to do, but it is starting to put an evidence base in place so that the money that's paid is the scenario that's been predicted is actually going to have an outcome that we want to have. But there's another thing in here. It's not just about flood risk, as we've talked about this morning and has come through over the last 7 years in the Natural Capital Committee. The point is, if you start to conserve particular aspects of nature, in fact, you can get multiple benefits from the same asset. So I just wanted to take this example just to make this point. So if you've got your tree planting, let's say the elm scheme kicks in and your farmers or your landowners in that area are paid to plant these trees. You're not only going to get water flow regulation and reduction of flood risk in Oxford, what you'll also get there, if you plant tree species that are fast growing and good for CO2 sequestration, you're going to get your atmospheric and your carbon regulation in there. You'll also get soil erosion protection. If you add features that enhance your biodiversity, such as pollination-friendly flower mixes and bat boxes, then you'll get your thriving wildlife on top of that. And finally, if you start to add features that increase recreational potential of this environment, then also you're getting the added benefits in there of physical and mental well-being. And each of those benefits carries with it an economic value. Each of those benefits is a public good. And so therefore, by starting to think about, first of all, your spatially constrained assets, but then layer on top those other ones, you can start to get a really powerful argument for why you should be paying public money for the public good, in this case, planting trees north of Oxford. But what about bigger, better and more joined up? Do we do this at the sort of just generally hoping that we're going to somehow this is going to happen across the UK landscape by more and more people being inspired, or rather, can we help that process as well? And this is something that I think is start to think about what are the next approaches we need to be thinking about in order to do this. This is one that all ecologists back away from, many biodiversity scientists back away from this as well. But I think there are some really interesting things coming through right now, which I do think will start to help. First of all, though, as we talked about before, we do need a baseline understanding of the current levels of fragmentation and fragment size and condition. So as we're talking about this morning, that very much that top-down approach, what does England look like in terms of fragmented landscape, be it grasslands or be it woodlands? The second one then is we need to establish where is the optimum location for joining up similar types of fragment. So again, a top-down approach. And then finally, once you've worked out where those locations are, this is where you absolutely have to bring in the financial incentives via ELMS, via the nature recovery networks to really to encourage the joining of those gaps. And for example, planting forests in specific locations where you know you are starting to join up that nature network. So I think this is really then looking forwards. There are many models and approaches to enable these steps to now occur. And this is the time really to embrace these, to make sure that we are getting and taking a really scientific approach towards doing this. And I'll just give a couple of examples here. So the first one, for a long time, there's been some very good modelling approaches out there where you can look at a landscape, look at the land cover types, and model or at least understand which are the biggest fragments on that landscape. And there's now new models coming out where, and this is somebody did this for me the other day, where if you look at this graph here of southwestern England, what you can see is this is native forest fragments in southwest England. And so actually for the whole of England now, this model was run, and all those little, you might not see it, I'll focus in here. Right, so that slight patchy area, you see the river going, the boundary in the river going down there. You see that darker blue patch, that's the Forest of Dean. And go deeper, and then you can see those are the fragments of native forest around in the Forest of Dean. And all of that has been done using land cover maps and then running this FragStats program. So the first step then is identifying where those fragments are. So let's say you wanted to then join those up and start to do a network to join up the forest patches across this area. Well, the next approach is then to use this other modelling approach that's come through, which is graph theory. So graph theory is a modelling approach where it basically views each fragment as a point, and it looks for the optimal connections between a network of points connected by lines. So it's been used by conservation biologists in the last couple of years, and you'll see this one paper here, where they've redefined wildlife corridors in Belize in Central America by using graph theory. So you'll see the grey lines, you see the red on the, if you look at the graph on the right hand side, you've got the red, which are the actual current protected areas, and then the grey hatched areas in there are the areas they think would be best for creating a more joined up environment. So the final then to do this, is this possible in the UK? Absolutely. So this was using that same approach, and we just did it for southwest England, and we used another graph theory. It's the same approach where it's called the integral index of connectivity. It uses graph theory. It takes those forest fragments, and it works out which ones are the largest, which ones are in key positions, and then how do you join them together? And what it's showing in here, the patches that you see flagged up in red are really important parts of the landscape that if you're going to plant trees to connect native forest, that is where you plant them. So I've just given you that example to show you that these things, it doesn't have to all be a qualitative. You can actually take these quantitative approaches, but then at the next point is to start to discuss with the local landowners and the bottom-up approaches as to how you then deliver those connectivity points in there. So I'm just trying to get my slider to work again. Sorry, I've lost the connection. Here we go. Right, so the summary advice then from the NCC on data requirements and approaches. First of all, I think this is a point we need to keep making, is that the ability to map, measure, conserve and enhance England's natural capital assets is well and truly within our grasp. And 10 years ago, I would not have said the same, but there's been a huge shift in the way that we're working in terms of data sets and modelling. And by doing so, we have a real opportunity to leave the environment in a much better state for generations to come. But we do need to be quantitative and scientific in our approaches and use the best models, tools and data sets to provide these outputs. There's still far too much, I feel there's still an awful lot of sort of pushback thinking that we can do this stuff with a very qualitative approach and that will do. I really don't think it will do. We really do need to be thinking very, very strategically now about what and where to plant in order to achieve these outcomes that we are all in support of. I think many of the approaches, and we had a number of questions came back this morning when we talked about it, that people want it to be bottom up because it is landscapes they are on, and more often not they own. Absolutely, it's not telling people how to do it, but it is we need to be able to give a framework and to have those tools and technologies and model outputs that then people can use to make informed decisions. But the other point I'd really urge right now is that we don't become so tied up in unnecessary complexity as to make the whole approach only accessible to a few. So we do need to have platforms and tools where people can easily download this data without having to know the great details that are within those models. And then this is very much a pitch into the next two talks, really, because I am firmly of the opinion that without citizen scientists and NGOs, we're not going to be able to deliver on any of this. We absolutely need to bring in much needed buy-in and data collection approaches and delivery to make all of this possible. And this is why I think it's incredibly exciting to now be able to hear from Rosie wearing her National Trust hat and Josephine wearing her Earthwatch hat, because this is the way forwards, I think, for all of this. Thank you.
Thanks, Kathy. Over to Rosie, please.
Just unmuting myself.
Helpful.
So, can you hear me?
Yes, thank you.
Excellent. Right, thank you very much for the invitation to speak at this conference. I'm Rosie Hales, Director of Nature and Science at the National Trust. And you would be forgiven if you actually associate the National Trust more with historic houses and gardens. They are a very important part of our portfolio, but so are the 250,000 hectares of land that we own, which is about 1.5% of England, Wales and Northern Ireland, half of which is designated sites or priority habitat, and most of which is tenanted farmland. So as we actually face into the nature and climate crises, and as we actually exit the EU, the National Trust actually contains a little microcosm of many of the challenges we face across the country and the sorts of challenges that Kathy has just been talking about. Now, our strategy at the National Trust has 6 pillars, and the work I'm going to talk to you about today and my portfolio of nature and science really kind of cuts across 3 of these. For example, we look after many special places. We want to give them a sustainable future, but sometimes this means difficult decisions about where to prioritise resources. We aim to make a significant contribution to changing the state of nature in the UK, and we also aim to enhance the connections between nature and people, and particularly address the inequality in access to nature. So we need to manage our land for the benefit of carbon, nature and people. Now, we've all been very impacted by COVID and the very significant financial losses that the Trust has sustained have been reported in the media. Nevertheless, in renewing our strategy as we come out of or as we continue through the COVID crisis, we have actually recommitted to the same targets that we have for carbon, nature and people. We aim to be net zero in carbon by 2030. We have specific commitments around nature that are pinned to the kind of Lawton principles of bigger, better and more connected. And we aim to connect more people with nature and engage more people. So to understand the challenge of achieving net zero, we took an audit of our carbon emissions. And you can see here in a scale diagram that, in fact, agricultural emissions and investments are a very large proportion of our emissions, also our let estate and the goods that we buy and sell. So we now have a programme of disinvesting in fossil fuels. We need to be as green as possible in what we do in our day-to-day operation. We are developing a responsible procurement plan, for example, and continuing to develop our renewables programme. We're going to continue to promote low carbon, nature friendly farming amongst our tenants, but there is a big challenge and also a big opportunity in how we actually change land use to meet our carbon and nature objectives. So bringing these commitments together means we are now developing a big ambitious programme to transform land use for nature, carbon and people. We have our nature targets of restoring 25,000 hectares of new priority habitat and improving the condition of our designated sites by 2025. These now actually sit alongside our target to be net zero in carbon by 2030. Now, we estimate that we need to establish 20 million new trees by 2030 to do that, or that's the equivalent of creating 18,000 hectares of new closed canopy woodland. Now, in reality, we'll actually do that in many different ways by integrating trees into landscapes, wood pasture, as well as closed canopy woodland. And also restoring other carbon-rich habitats that are good for nature. We'll continue to promote low-carbon, nature-friendly farming, and we also have programs and aspire to deliver other public benefits, for example, improving water quality and natural flood management. So what's our starting point? Well, that graph on the right illustrates roughly where we are now. The blue bar is the area of kind of land that is agricultural. The dark green are priority habitats that are not woodland. The light green are priority habitats that are woodland. And then we have kind of wood and scrub as the very light green at the top. And I've not included urban and built land here. Looking to the future, we aim in future for our land to fall into one of these kind of 4 broad categories. So over 50% of our land is very important for nature conservation in the UK. So in that land, which I'm calling nature places, we need to do targeted conservation management, and that will be kind of moderately resource intensive. We have over 1,000 threatened species recorded on our estate, and we need to improve the condition of our habitats and the fate of those species. We've also committed to restoring new priority habitat and creating new places for nature and to sequester carbon. In the wider landscape, we will work with natural processes, and these it will be in ways that will deliver a range of public benefits and buffer and protect those more important designated sites. And where we do have high quality agricultural land, we will continue to farm and promote low carbon, nature friendly farming. Now, this program actually has a number of different elements to it. I've just presented with you with the vision, but we also need to understand our baselines. For example, the carbon emissions account I showed you earlier. We need to map opportunities and understand where we're going to have difficult decisions and choices to make. We're creating an evaluation framework which will evidence any uplift in public benefit. We're going to need to draw on a range of funding mechanisms. And one key point is, to be successful, we need culture and behaviour change that runs through individuals, communities, organisations, businesses and government in a consistent way. And along the way, we'll work with our research partners to fill evidence gaps and actually, work out and evidence what works best. So just very quickly to skip through some of those, there is a wealth of empirical evidence which actually illustrates what happens as your management of land becomes increasingly intensive. This graph is actually data taken from Countryside Survey, which does an audit of the countryside every 6 or 7 years, and it shows that as productivity increases, a number of other benefits that you obtain from that land declines. So there is no kind of one optimal solution. How are we going to map our opportunities? Well, we're drawing together the opportunity mapping that's been done by many other organisations, and we can apply constraints to actually look at, what our options are. So, for example, if we wish to plant new woodland, we would want to avoid designated sites and high carbon soils and steep slopes and urban areas. And then we can apply additional constraints or play around with them to actually see how they alter our opportunities. So here are some examples of some of the data layers that we're using that we're then overlaying on National Trust land. For example, the Environment Agency and Natural Resources Wales commissioned a very useful piece of research in how we can actually work with natural processes to alleviate flood risk. And as part of that output, they produced a set of strategic maps, and we can actually use these data layers to give us an idea about where we could reconnect floodplains and where it would be sensible to sort of do floodplain woodland creation or riparian planting or wider catchment woodland planting, for example. And of course, Natural England have produced their habitat opportunity maps, where they identify areas for potential future priority habitats. But as you know, with all these layers, we need to recognize it's only one slice of the picture, and we need to consider these data in the context of local knowledge and the landscape context. We've been considering, when we overlay this on National Trust land, where they identify synergies in our objectives and where they identify conflicts. So here I've got a range of National Trust sites. Of course, they vary in their size and the opportunities they present, and I've just ranked them according to total opportunity. And the key point here is that where we have orange and green, we have opportunities for priority habitat and woodland, and where we have blue, we have potential for conflict between different objectives. And so you can see, even from this very first preliminary, very crude look at the data, there will be some situations where we have to make some difficult choices. Now, of course, it is also the case that the interventions that we might propose, particularly creation of woodland, are going to alter the way our landscapes look. And much of our kind of cultural and historical values of our landscapes are being captured in landscape character assessment. So this is another element that does need to be brought into play to help us balance the choices we make. And this is perhaps a harder aspect to consider. We must also evidence the uplift in public benefit that might result. So we are developing sets of metrics that will measure outcomes for people, nature, and carbon. We won't always be able to actually directly measure those metrics. Sometimes it will be measuring proxies, sometimes it will be modeling, and sometimes we'll be inferring relationships from the literature. But we will also capture our progress in dashboards. Now, and this is an example of our nature dashboard, which we have already developed. We can see how the different regions are performing against our targets across the 7 regions and countries that the Trust covers. And we can also disaggregate this further within regions to look at individual properties. We'll be developing these sorts of dashboards for other elements of natural capital to really evidence our progress. So we have the vision, the data, tools and metrics and evaluation frameworks, but most of our land is tenanted. How do we incentivize tenants to work with us? Well, we're working on a range of mechanisms. Crucially, agricultural subsidies are changing, and we want to get our tenants in the best position to take advantage of the new environmental land management scheme as it comes on board. But we're also looking at internal incentive mechanisms and blends of public and private finance. And in collaboration with Green Alliance and others, we've been piloting some work on a natural infrastructure scheme. And this is kind of building on the work of actually people in the Natural Capital Committee and others. We know there's a market for slow, clean water because that will reduce treatment costs and the need for flood defences. So the customers here are local authorities and utilities as well as individuals. We can provide slow, clean water through land management practices. So land managers are those service providers. And then the difference in cost between the land management that's required and the alternative ways of providing slow, clean water provides a trading space where customers and suppliers can negotiate. We've been running a pilot of this, and we're now considering how this could be adapted to provide other environmental services. So my final slide just kind of summarizes our approach. We're working towards these targets for carbon, nature and people, and I have not really had time to talk about our access targets and how that layers onto all of this, but we have a real sense of urgency. Time is against us, so we aim to be bold and learn by doing and adapt as we go. And we certainly need to be imaginative in the financial mechanisms we develop. But we also recognise that many of our tenants share our values, and we have some great examples of working with our tenants to deliver these kinds of outcomes. And we need to really build on those for the future. So thank you very much for listening.
Thank you very much, Rosie. And let's go straight on to Josephine Head, who's going to tell us about the citizen science part of this and some of the experience of Earthwatch.
Thank you. I'll just check yes, it's still working. Okay. Thank you very much. Good afternoon, everyone. And thank you very much for the opportunity to speak with you today. I'm Jojo Head. I'm the Senior Research Lead for Soil and Water at Earthwatch Europe. And I'm going to talk to you today about citizen science and its potential to inform the natural capital approach. And to give you a little bit of background about Earthwatch, it's an environmental charity which very much has science at its heart. And we connect people with the natural world and monitor the health of our natural resources and inform the actions that will have the greatest positive impact. We work together with a really wide variety of stakeholders, from scientists and businesses to civil society and policymakers, to drive positive environmental change. And we're recognised as an independent research organisation, and we use science to better understand the environmental challenges that we face and to find solutions to these issues. And crucially, hence this talk, we're leaders in and passionate advocates of citizen science, which I'll explain a bit more in detail in a moment, but it's essentially engaging the public in research. And moving the wrong mouse. At Earthwatch, we have a strategic focus on impact, solutions and innovation across 4 key themes. The first is freshwater quality. We also have a programme of work around sustainable agriculture, climate-proof cities and coastal health. And for those of you who are less familiar with the term citizen science, essentially citizen science is scientific work undertaken by members of the public, often in collaboration or under the direction of professional scientists and scientific institutions. And citizen science is a really broad field that includes anything from educational experiments to the Big Garden Bird Watch, and from volunteer biodiversity monitoring programmes to opportunities to contribute to research from your own home by counting, for example, the number of penguins on remote video cameras. And as long as an activity involves members of the public and contributes to science, it is considered citizen science. And one key point to make about citizen science as well is that it creates both science and engagement benefits. So it raises awareness and educates, it's a source of environmental data, it creates collaboration and shared understanding, and it also empowers actors to create change. In the next few moments, I'll provide some examples of the impact and benefits of taking a citizen science approach and how it can be deployed to create positive environmental impact. And I'm going to use Freshwater Watch as an example of citizen science. When Kathy spoke about the Even Load project earlier, that's part of our Freshwater Watch programme as well. So I'm going to use that as an example of the impact that citizen science can have and to explore sort of some of the different types of citizen science participation. So Freshwater Watch is a global water monitoring programme that assesses levels of nitrates, phosphates and turbidity, among many other potential parameters. And it's based on an app and web platform. All of the data is open access, and using Freshwater Watch doesn't require any prior training by participants or subsequent laboratory analysis. Instead provides immediate results to participants on the ground. And so far, think freshwater's been going for about 7 years now, could be a bit longer. We've engaged over 28,000 citizen scientists in 60 projects across 6 continents. And the methodology that we're using has gained interest from UK and EU policymakers and has had a significant impact in terms of empowering communities and farmers. And thus far, we've had over 30 peer-reviewed publications from different projects using Freshwaterwatch. And I'll continue using Freshwaterwatch to demonstrate a bit how citizen science can have a significant impact on management, behaviour and policy. So here we can see, this is a map, I believe, of the Thames catchment. And we see how a kind of citizen science monitoring approach to freshwater can provide a real snapshot in time at a very detailed scale, which provides those who are managing water quality with a really comprehensive picture of pollution hotspots within a water catchment, which can enable informed decision making and making and targeted interventions on the ground. And there's a little quote I put in from the Environment Agency that kind of highlights the utility of this data, saying, you know, the information has been invaluable and helped us and our partners to target pollution prevention advice and solutions to businesses in the area, tackling pollution right at its source. And you can also see the positive impact on behaviour among the citizen scientists themselves. In this example, 99% said they have better understanding of their personal environmental impacts, and 95% reported having reduced their impacts as a result. And if we consider citizen science and Freshwaterwatch in the context of payments for ecosystem services and ELMS, it's easy to see how this kind of approach could be appropriate for farmer-led monitoring of water quality for ELMS payments. And in fact, Freshwaterwatch is being used with some farmers in some of the ELMS trials currently taking place. But Freshwaterwatch has also had a broader impact on policy and management at national and international scales, and gained recognition through peer-reviewed articles and policy documents, and the methodology has been promoted by the UN, the EU, DEFRA and the Environment Agency. So, for example, the UN recently published a study where they compared our Freshwaterwatch data with laboratory data and concluded that Freshwaterwatch is a cost-effective way to monitor a broad range of parameters for the Sustainable Development Goals. As Kathy highlighted, the Natural Capital Committee called for an environmental census using citizen science in their latest response to DEFRA regarding the 25-year environment plan. And the EA is also taking a really keen interest in citizen science and looking at ways to integrate it into their monitoring programmes, and beginning with water quality, but we hope sort of going more broadly. This has all occurred, so to take a sort of wider look at citizen science and take a step back, this has all occurred in parallel with significant growth in citizen science generally around the world, and also development of the way that citizen science is done over that same time period. And today there's a very active international community and agreed standards and principles for citizen science. And data quality of citizen science is, at this point, I would say proven, but I'm happy to be rebuked on that. And there are strategies to ensure that quality is in place. And Earthwatch has very much been at the forefront of this, working with these different stakeholder groups I mentioned to really drive forward the science of citizen science. And I provided an example for water quality, but we're also undertaking similar initiatives around soil health and tree planting and biodiversity. And I don't want to spend too much time on this next slide, but just thought it important to mention that one of the biggest sort of developments over the past few years is the recognition that citizen science is like a broad church and there's no one-size-fits-all approach. And we've developed a framework that recognises 4 distinct citizen science approaches that are particularly suitable to create positive environmental change. And the approaches, they differ markedly in terms of what audience they appeal to, how you set them up, at what scale they can create change, and also how they create impact, mainly through data collection, which can feed into management decisions and policy, or whether they're more focused sort of on awareness raising and education. And I won't go into too much detail, but again, happy to follow up. But in short, the first is interest group research, things like farmers or bird watchers or fly fishers who collect data that are relevant to them, but which can feed into national monitoring and research programmes. The second group is captive learning research. So, for example, school education sessions or employee training programmes that incorporate environmental research to create a deep understanding and connection with a particular topic, and encourage participants to change their behaviour and spread that message more widely among friends and family. The third is place-based community projects, which enable local groups and stakeholders to work together to monitor and improve their local surrounding area and become stewards of their local environment. And the fourth is mass participation censuses, which are large-scale campaigns with a very, very easy task that allow a wide range of people to get involved and create a snapshot of water quality, like the example I showed before, or bird populations or air quality or whatever it may be over really large geographic areas. And so to summarise on citizen science, it's not one approach, but it's kind of a collection of powerful tools that bring together researchers and the public and a range of stakeholders to create data and evidence, and also promote collaboration, understanding and motivation. And depending on the chosen approach, this can create changes in institutional, collective and individual practice or policy through a range of different pathways, including evidence for policy, environmental management and political advocacy, among other things. So to come back in the last section to the kind of primary question, which is how citizen science can inform a natural capital approach, Kathy and others have already spoken of this need for baseline data. So if we take the 25-year environment plan as an example, I think there's a very clear role for citizen science approaches to provide that baseline data on the presence and status of natural capital in England, to inform the 25-year environment plan indicator framework and enable progress to be measured against the 10 goals. And this word cloud I've created kind of highlights just some of the headlines and indicators that I've pulled from the framework, and for which there are already established and robust citizen science approaches to monitoring that can be used to collect that data. And in terms of the complementarity of citizen science data to statutory monitoring and in filling knowledge gaps, some of the advantages, which again Kathy's outlined, include the scale at which citizen science can be undertaken, and these kinds of approaches enable robust data to be collected at scale, both in terms of like kilometres squared covered, but also sampling density, and also frequency of data collection. And this can really complement other monitoring or traditional monitoring approaches and fill in existing gaps. And what we've really learned through years of experience is it's really about using the right method in the right place. And I just want to finish up with the most recent example of a mass participation approach that we carried out with Freshwater Watch, which was a water blitz of the Thames catchment that took place in September. And over 4 days, over 800 volunteers collected more than 900 samples across the Thames catchment. And interestingly, more than 10% of participants took part to investigate a specific local concern or to measure impacts or improvements they'd already undertaken in their local water bodies. And the results provided a really impressive snapshot of the health of water bodies in the Thames catchment. It did show that only 6% of flowing waters were currently in good condition at that time. And in terms of the sort of policy relevance, the Environment Agency have already kind of recognised the potential for this approach to feed into their national water quality monitoring, and they're currently supporting Earthwatch to take forward 2 programmes. The first is to use the results of this blitz and other Freshwater Watch case studies to develop worked examples of how citizen science data could be effectively integrated with Environment Agency water quality data, and then secondly, to develop a roadmap detailing how we could upscale this approach to the national level for water quality, but also for other metrics where citizen science approaches could measure natural capital. And thank you very much for listening.
Well, thank you very much indeed, Jodo. That was just excellent and actually very exciting as to what can potentially be done. And I think the 3 sessions we've had in this part have all fit together. And hopefully we're going to see more of that when we come to the Q&A going forward. But thank you to all 3. We're going to have a break now until 3:05, when we'll start promptly again. And then we're going to listen to Chris Collins and Melanie Austin. And then we've got half an hour of Q&A, and I'm sure there's going to be quite a lot of questions coming out of this session. And I'm certain they'll be out of the next. So let's break now and see you all back at 3:05. Thank you.
So a very warm welcome back to the Natural Capital Committee's Science Conference. So this is our final event, really on for 7 years. And I'm Kathy Willis. I think if you've just joined, I have been on this committee the last 4 years. And the last two speakers in this session, most appropriately, are my two partners in crime on this committee. The first one being Professor Chris Collins from the University of Reading, who to really keep reminding us how important soils are in terms of a natural capital framework. And then the next person to speak will be Professor Melanie Austin, who keeps reminding us on the committee day in, day out, we must remember the marine environment. And they've been incredibly effective at making us bring these very, very important assets onto the table and considering them within a natural capital framing. So I'm first of all going to hand over to Chris, and then we'll come on to Mel, and then we'll have the final questions and answers session, which will be chaired by Dieter Helm. So Chris, over to you.
Great, thank you very much, Kathy, and welcome everyone. Just like to say what a privilege it's been to be on the committee, and Dieter has led it fantastically, and I've really enjoyed the companionship of my other committee members, and I've learnt so much. So thank you to everyone over those last few years. So I'm going to talk about how we might build soils natural capital and highlight some of the issues that I think have prevented us doing that. And at the end, provide what I call an oven-ready deal so we can start building that natural capital now. So soils provide a number of ecosystem services that many of you will be aware of. The sort of principal ones most people refer to are carbon sequestration, water purification, climate regulation and nutrient cycling, as well as the provision of food. But there's other sort of more subtle ones that are often forgotten, and we referred to that this morning about the sort of biodiversity in the soil and how that's a sort of principal source of pharmaceuticals. Up to 50% of our antibiotics come from soil organisms. So our soils are under considerable pressures. I've given two examples here. On the satellite photo on the left, this was after one of the heavy storms during 2 or 3 years ago. And you can see there's significant soil erosion occurred, and that can be seen in the Bristol Channel, where you've got the very heavy sort of brown colour affecting the channel, where you would expect a sort of more of an aquamarine colour. And then the right-hand side, the very famous Holme Post in the Fens, and that was first planted in 1870, and it's now 4 metres above ground. And that has been a result of two processes, drainage of the Fens for agricultural production, and also erosion as a consequence of the lighter, non-wet, non-drenched peats being eroded quite easily by winds. And obviously, as they become aerated, those fenland peats can become oxidized, and we lose carbon from those peats. And peats are a vital carbon source critical to our delivery of net zero. So we've done some evaluation, but Cranfield led this study looking at degradation of soils, and this valuation came to about 0.9, 1.4 billion. And again, that was principally down to loss of soil carbon as a result of greenhouse gas emissions that were consequent from that carbon loss, but also the replacement costs of those carbon. In this study, quite a crude study, they used the cost of replacing it with manure. But that probably underestimates a lot of the role that carbon has in soils in other cases, like water retention and water filtration in order to remove contaminants. So I would say that's probably an underestimate, but it does, one study, it does prove that we can do some evaluation of some of those ecosystem services that soils provide. So we've been, the first bit of legislation, if you like, the first aspiration to manage our soils sustainably came in the Safeguarding Our Soils document from 2007. And that targeted 4 issues whereby we were to manage our soils more sustainably. So our agricultural soils were to be better managed and threats against them addressed. Soils would play a greater role in the fight against climate change. That's principally about reducing NOx emissions, but also enhancing the carbon content. The soils in urban areas would be valued, and their development in construction practices would be addressed. And then the pollution of our soils would be prevented and contaminated land legacy dealt with. But I think you can quite easily argue, if you look at the data that we've presented, that on all 4 of those targets, we're failing currently, or we're not dealing with them as well as we potentially could. So we know what we've got to do, but we're not doing it just yet. So why have we not delivered on those sustainable soils? Well, I think there's 4 key reasons, and I'll try and address these in the rest of my talk. So I think there's a perception that soils are inherently complex and therefore difficult to deal with. And that's resulted in disagreements around metrics and about whether we need different metrics for different soils, for different land uses. That might be true, but I think we can address that. As we referred to throughout the day, we have no real baseline. We've got a few snapshots of what the state of our soils is, but we do not have sort of repeated measures at 5-yearly intervals, for example. And really the regulation around soils is minimal if you contrast it with air and water. And I think we do have to be thinking about soils in the same breath as air and water. So this just gives you an idea of the complexity of the different soil types across England and Wales. The purple areas are our blanket peats, the red areas are our freely draining sandy soils, and the yellow areas are our sort of more base-rich soils over limestone. So though our soils are very, very diverse, we do have good knowledge of what they are and where they are in the country. So we can adapt metrics to each individual areas, and as Kathy showed earlier, we can quite easily use that sort of soil information to look at where we might want to regulate water flows. So as I said, there's been some discussion about what the most appropriate metrics are and how do we design a campaign. Well, we've done it twice already. We did it with the National Soils Inventory run out of Cranfield, and then we did the Countryside Survey run from the Centre of Ecology and Hydrology. But also the Environment Agency in the mid-2000s got together a lot of stakeholders to design a UK soils monitoring network. So we already have a monitoring scheme in place ready to go. And if you just look at the right-hand side of the slide, you can see that they developed for certain land uses, arable, permanent managed grass, managed semi-natural grass, action levels for, this is for soil organic carbon. So for arable, they wanted a progression towards 50 grams per kilogram for England and Wales. And then in permanent managed grass, they wanted that to go up to 75. Usually in grasslands, you have higher soil organic matter than you do in arable rotations, mainly due to the permanent vegetation cover, but also due to the lack of tillage before each crop. And this is another stakeholder workshop where we were looking at the different land uses. Here we chose 4 land uses: urban, intensive, extensive and forestry. And then we looked at 5 indicators, well, sorry, more than 5, 6, 7 indicators: organic matter, water retention, earthworm structure, nutrients, microbial diversity and contaminants. And we were looking at the key questions that the stakeholders had raised. One was, what was the relationship between management and soil health? And these went right through down to the communication of different soil health indicators to practitioners. And you can see that organic matter features in virtually all of those landscapes as a key indicator when we're addressing those different questions. Urban is slightly different because often the concern is around contamination. Sorry, it comes too quickly. So I said we've done a number of surveys. This survey I'm showing the data from here was undertaken by the Natural Resources Institute, now part of Cranfield University, and they looked at the rate of change in carbon between 1978 and 2003. And you can see here that there was quite a, if you look at the contrast between those two dates is on the right hand side and the original values are on the left hand side. And you can see the bigger changes, the dark blue colours, tend to be in those areas where we have peats, where we're seeing sort of erosion due to drainage, but also one of the most significant changes was in arable landscapes. And you can see that towards the east of the country. So we know when we do national surveys, we can pick out key changes in our natural capital. So we can do the surveys and we can prove that we are seeing these changes over time. And it's really critical that we maintain these. There hasn't been a national survey at this scale since 2007, which was the last countryside survey. So one of the things that I think we've really not been able to deal with is there's been very poor regulation of soils. This was one of the issues in Europe. There was going to be a soils directive, but this didn't come about because the northern industrialised countries such as the UK knew that their soils were polluted and they may well have to spend a significant amount of money to bring those up to natural levels if they ever could. So I think that's why we don't have a directive such as the Water Framework Directive. But standards do exist for soil contamination. That's predominantly an urban problem, so in terms of total coverage, it's quite low. We do have the good agricultural and environmental condition requirements as part of the basic payment scheme, but it's very easy to get a derogation for that if you've had a difficult year. There's very few inspections to discover non-compliance. One report I read recently said there was only 2 prosecutions in 2015. So that just shows you the level of coverage that the EA has, probably just due to resource limitations. But they don't really combine a holistic approach to soil health. So we need something stronger if we're going to really improve our soils. And then for many habitats, such as woodland, we don't have any regulations at all. So really weak regulation around soils. However, we do have, certainly for arable land, we know how to restore soils. That sort of 4 key principles: provide continuous living roots, they pump carbon into the soil, so we're always enhancing that carbon, and that carbon feeds the biodiversity within the soil. Minimize disturbance, that stops oxidation of the carbon. Maximize soil cover, that reduces erosion, which can have ongoing impacts on improving in treatment of water. If you've got a lot of dissolved organic carbon in the water, it makes it very expensive to clean for drinking water. And then we also want to maximize our biodiversity by using things like cover crops with diverse seed mixes. These can be turned into 6 key management actions. So you reduce inversion tillage and reduce soil traffic to prevent compaction. You increase your organic matter inputs, use cover crops, manage nutrients and rotate crops. And finally, reduce the pesticide usage because that can have penalising effects on some soil organisms. So just briefly then to conclude, the oven-ready deal for soils, as I see it, is we need to give soils the same protection as air and water. If you look at the improvements in our water quality over the last 15 years, they've been quite remarkable. We could do the same for soils. Soils need to be placed at the heart of the ELMS scheme. We don't want the weak regulation that's gone with the good agricultural and environmental condition. And we need to take a census to develop the baseline of our soils. And I've showed you some good data as to why that can lead to some really good outcomes in how we start to address the problems that have been identified. Thank you.
Brilliant. So thank you very much, Chris, for a really clear and positive approach to looking at our soils, what the problems are, but also where there are some very clear solutions in there as to what we should do. So our final talk then this afternoon is Professor Mel Austin, who's at Plymouth University, and she's now going to give us the marine version. Marinisation is a word that I've learnt from Mel. Every time on the committee we don't mention marine, she comes in and marinise us. So Mel, I'm handing over to you now to give us a take on the marine natural capital asset.
Thanks, Kathy. Okay, so yes, these are the three reports, one of which was totally marinised because it was the Marine and 25-year Environment Plan. And the two other reports that I want to mention in this talk, which one is about nature-based interventions, and the other one is our response to the progress of the 25-year Environment Plan. And I'm going to start with the one in the middle, the Marine and the 25-year Environment Plan, because this is where we started to make some recommendations about marine and where marine should come in. And I mentioned some of these recommendations this morning. I think really for marine, we need this holistic approach to protect and grow our marine natural capital. And there are lots of benefits from that. And at the moment, most of the actions that are taken are in relation to protected areas. And I'm sort of rather taking the assumption that most of my audience today is actually terrestrially based. So I'm afraid I'm going to try and marinise you all a bit today with largely some pictures of things that make you start to realise just how diverse but also important the marine environment is. So here we have quite a lot of carbon capture going on with kelps, but also with salt marshes. The salt marshes and the kelps also help with flood defence and regulation. Our overseas territories have a lot of coral reefs, so they're still very relevant to UK waters and to UK management targets. These environments have a wealth of biodiversity, from things that we think are quite iconic, to things that we eat, to things that we didn't realise how beautiful they are, unless you're somebody who does go and engage with the marine environment as a diver or as a snorkeler or goes rock pooling, and then you start to realise just how much there is out in the marine environment. And that provides us with a lot of benefits. There's the huge increase in energy, renewable energy that we're seeing. There's aquaculture, obviously the shipping, but we tend to forget, as we discussed this morning, the huge recreational importance of the marine environment, the blue spaces. So we think about the green spaces, but not so many people are aware that for coastal communities, those blue spaces are really important. And they're also why a lot of people visit the coastal areas of the UK, of England, as well as overseas, is for that recreation, for that leisure, and for that general sense of well-being, of just sitting and being in front of blue spaces, which has huge benefits. So these are really important, that we need to bring in all of these facets into our decision-making and into our policy. We do have some legislation that we can do that. We can do it with the Marine and Coastal Access Act, because these are where we develop the planning policies and where the licensing decisions are made, as well as thinking about what can we do in addition to the marine protected areas, because the marine protected areas tend to be protected for very specific things rather than for natural capital growth more generally. So they're not targeted at natural capital growth in a way that I think they could be in the future. The marine and terrestrial are intimately connected. What comes off the catchments goes down the rivers and eventually ends up in the coasts and the seas. And similarly, the drivers of change in the marine environment are very, very affected by what goes on land, or basically by the people who live on land. And this schematic sort of just shows you some of the values that we're very aware of, the food values and the energy values, as well as the incomes, which all have our market values that we know about, but we tend to forget about all of these other values. The greenhouse gases, huge amount of greenhouse gas, carbon sequestration locked away in the marine environment, the biodiversity of iconic importance, the recreation and health benefits, and the flood defence benefits. So if you look at this picture, then it is very much more than just the fish that we're talking about for the marine environment. And yet even in the 25-year environment plan, the focus is very much on that food value rather than all of these other values. And that's where I'd like to see things changing, and it's the recommendations that we've made from the committee. And these obviously all have social values. So some of the legislation that's developing is around good environmental stewardship, and with the committee we've looked and sort of said, well, there are things that landowners can do to reduce their impact on the coast, particularly if we think about that drainage from catchments, and that could be part of the environmental land management schemes. But at the same time, there are quite a few marine developers and marine users, and I think there should be some incentivization for those users to enhance their stewardship of the marine environment. One term is greening the grey. So if we're, for example, building renewable energy devices, they can be more biodiversity friendly. They could incorporate aquaculture. They might be magnets for protecting marine life. And potentially they can be quite good places for fishing, sea angling, and other recreational purposes. So there are potential benefits. And these can really come also if we start to think about environmental net gain and apply that to marine activities. It's almost easier to think about environmental net gain in the marine environment than it is biodiversity, because we tend to think about these bigger picture things, even if we don't regulate for them. As I've said, there are a lot of physical and psychological health and well-being benefits, and government could be improving public access and enabling more benefits from the marine environment than it probably does at the moment. There is a huge amount of scientific understanding, and we don't tend to think about it in a natural capital context, although we are increasingly doing so. But we could bring a lot of this scientific understanding in the way that Kathy's talked about terrestrial, about flood management. We have some really great models, but we don't tend to think about them in context of climate regulation and waste regulation services. But we can enhance these, and we can use some of our modelling to thinking about some of where we allow discharges into the sea. We can increase food production with better use of science, improve natural flood defences, and think about how we can enhance the wildlife that people enjoy watching. But also I think we need to have more effort to think about, if we could get all of this right, what would success look like? What do we actually want from the marine environment? Is it really just fish, or is it all of these other things? And how do we understand and think about the trade-offs that are involved? So the next paper that I want to talk about is the response to the 25-year Environment Plan Progress Report. We divided up assets into biotic assets and abiotic assets. So for marine, this felt like a very strange thing to do, to separate biota off from the physical chemical characteristics of the marine environment. But we did manage to do it. We thought about the marine asset, the components of the asset, and that's the seawater, the seabed, coastal, as well as the marine and coastal processes. So it is feasible to do this. And we also added on here marine litter. So although it's a pressure, it's very much writ large in the 25-year environment plan for marine. We do have a lot of components and things that we can measure in terms of condition and extent. And you can see some of these here. And this report, we went through many of these measurements trying to find out, well, what data is there? Is it spatially representative? Can we actually see, what trends can we see from it as part of our report? Our overall rating and assessment was that the marine environment is red deteriorating, and that is on the basis of these two things: litter's increasing, some of the coastal waters are not meeting the good ecological status targets, and not all of bathing waters have achieved sufficient status, although there have been considerable improvements. But the key thing was the data didn't allow for much more of an incredibly partial assessment of the extent and condition of these assets. And that was very disappointing. If we look at the assessment, pretty much in all of these, it's basically saying we're lacking in data, we're lacking in data. Of sufficient spatial coverage, there's quite a lot of modelled data, and some of that modelled data is really, really good. Let's not quibble about that. We have some very good model data, but we don't necessarily have the underpinning validation of those models to say, yes, this is what is happening at the moment. We're basing that on some good scientific understanding, but we don't have the monitoring that's going on that we need. There are some clear trends going on. Climate-driven change is happening in the marine environment, and it's happening very fast. pH levels are decreasing. There is ocean acidification. We know that's happening. Extraordinarily, although there is actually a lot of carbon in the marine environment, in the water column, in the sediment, in the primary production that takes place, we don't actually have enough data to assess the role of marine environment in that, how that role is changing over time. Is it getting better? Is it getting worse? We know it happens, and we know the extent to which it happens, but we don't know if it's improving or not. Again, surprising lack of targets in the marine environment. We need more targets, but we do have enough to know that warming seas are really affecting UK coasts and seas. Climate change is happening. So we had a lot of recommendations, largely around that. Although there are challenges, we do still have to seek mechanisms to actually do monitoring, to get better understanding. We need to address those data gaps, and Kathy talked in detail about how you prioritize those data gaps, but also how you start to address them. I probably won't go into too much detail here. We do need to set targets. So most of our targets are for marine protected areas, but there's a huge amount of sea that is not protected. And those marine protected areas haven't been protected with the idea of natural capital and looking after our natural capital and growing it in mind. Therefore, I think we have to think beyond the marine protected areas. We have to go beyond that current focus on MPA condition, marine protected area condition, if we are going to improve the marine environment. So said organic carbon should be a priority. There are indicators that the cycle in the system is changing, but we don't have the data to really be able to say so. 55% of carbon is in, biogenic carbon is in the marine environment. We don't call it biocarbon in the same way that people do terrestrially, but there is a huge amount of carbon there. And as I say, we need to take a much more systems approach to monitoring the environment. If we start to work out how to monitor it properly, then we also can start to work out how to prioritize and reduce future monitoring needs. And I think this is where the baseline census is really important, that we really consider that for the marine as well as for terrestrial. Another area in that report is around biota and asset, the biota asset components, and obviously this includes marine. I just want to highlight that in the biota assets we talked about species which are critical for ecosystem function, that support other flows or ecosystem services. They're rare or iconic or protected species. I just wanted to demonstrate that in the marine environment we do have biota that fulfill all of these, and an awful lot of them, and yet we're not monitoring them. There's very little data. Finally, going to nature-based interventions, this other report, the third one. Again, we've talked about net gain this morning, particularly for marine. I think it's vital that we replace we actually include net gain, and that it's environmental net gain if we want to think about how we can improve terrestrial and marine ecosystem. There's an awful lot of net zero targets which are going to involve the marine environment, but these need to also be joined up with spatial planning for nature-based interventions. Nature-based interventions are possible in the marine environment. There are a lot of biocarbon stocks, as I've said. I'm just going to give one example, which is the kelp forests. Kelp forests, as they grow and as they degrade, export carbon offshore into the seabed and then further off into the deep sea. But at the same time, these kelp forests are really important for food. They act as a nursery for food fish species. They're recreational importance. So we need to think about it in beyond just the carbon that those forests and that the marine environment provides. And the marine environment also gives us an opportunity to think not just about mitigating greenhouse gases by bringing more carbon into the system, the natural system, but also about adapting to future climates, particularly in terms of flood and storm defence. And again, in this project, in this report, we mentioned that monitoring programs for marine are pretty inadequate. So this is a recurring feature of the Natural Capital Committee, is that we need to do more on getting better marine data. So finally, I've given a skip through these three reports from the Natural Capital Committee, and it is the Natural Capital Committee, not the MTU Atoll Capital Committee's publications. Please do have a look at these, and there's so much more on that website, and a lot more of it now includes marine or has been marinized. So I'm really pleased that I've had the opportunity to come onto the Natural Capital Committee and try and marinize some of the really fantastic work that it's done. Thank you.
Thank you very much indeed, Mel. That's been great, and you certainly have marinized us. I shall take that word away from our activities. We now have just over half an hour for Q&A before I'll try to make a few remarks at the end about how we put together the science and the economics. And I think Colin's coming to join us for this discussion. Just checking. And I also have the questions up here, but I have them very small on my screen, so I'm finding it very hard to see what's there. Can we just put those in a stronger format, please? Is that possible from our support team before I kick us into the questions themselves? That's not going to happen immediately, so I'm stretching to see these questions. Just hit it. What does that involve doing? I'm struggling to know what you want me to do.
So there's a pin on your screen which says Stream 3B pin. Can you see that icon? It's there.
Whereabouts is that?
It'll be on the left-hand bottom corner.
Left hand. Then we'll take some questions from the top. So what I'm struck by in all these presentations is that every single one of our speakers knows what we need to do. The question is how to put this together into a comprehensive database for the OEP, because the OEP takes over from the Natural Capital Committee to ensure that it can carry out the checking of the government's progress against the 25-year plan. So Kathy, with our national census, the natural capital census concept, and with Jojo's citizen science, etc., and taking what we've learned from the National Trust, from the marine side, from the soil side, how do we make it into one coherent whole, which is the legacy we're going to give to the OEP to carry out their functions?
I think some of that work has already been done in the sense that it's identifying, well, first of all, I think everyone who spoke today has a fairly clear idea of the sort of metrics that should be measured. And also, I think we've got a pretty good idea now of where the spatial and temporal data gaps are. And so it's really not reinventing the wheel. It's building on those data gaps we already have to say, let's have a citizen science program. I was very taken with Jojo's talk. You know, let's have a blitz in this area. Let's try and get these particular data gaps filled quickly. But it does need one person or one organisation to basically manage that, to control it, so that we do have a proper set up, established census that you're able to then reproduce in subsequent years.
And that, do you think that should be in the OEP doing that and resource to do that? Do you think that should be in DEFRA, or do you think that should be an independent body, or do you think it should be just an amalgamation of different parties, a kind of confederacy?
I think it probably does need a controller in the middle, and I think it probably should sit with DEFRA probably, because I think the OEP has got a different set of functions. I would think there should be a team in DEFRA that is doing that. Then bringing in, the Environment Agency to come up with the ideas for how are they going to fill the data gaps with the water. There are all these different groups that could be brought in to do a chapter by chapter, but actually making sure that there's not duplication and it doesn't become too complex too quickly. That's the other problem. We're very good in this country of wrapping ourselves up in incredible complexity, when actually a lot of those things you don't need that level of complexity. And I thought Chris's talk illustrated that beautifully. Actually, we know what we need to do, and many of these things we've already got the mechanisms in place to do it. We now just need to have the vision and the determination to go on and do it and get it on, get going with it.
Yeah, so I think that I think we can reasonably say that what we've done in the Natural Capital Committee is set out what needs to be done and the framework in some detail of what's required. The question is someone prepared to do it? And that's whether the proof will be in the pudding, is whether the Environment Bill delivers on its promise. Now, there is a question which I can just about read at the top here, still in very small print, which is about the use of these various approaches for the target setting. So I'd like to call in Chris for any thoughts he has about how we could set targets for soils. I know it's not one of the listed 4. And perhaps Melanie might make some comments about what we might do to use what you looked at to set targets for water, the water territory. And then we'll, if we've got time, come to Jojo and Rosie about how those would, in Rosie's case, how they would impact on what the National Trust's doing, and in Jojo's case, how you can contribute to that target setting process in addition to just creating the frame. So Chris, if we're to have serious targets for soils, and that's not there yet, it's not in the first 4 list, how would we do it, and how can we use what we know to say this is the right target as opposed to some other level?
So I think, to me, it's about identifying landscapes, and then once you've identified the landscapes, to then develop the targets within those landscapes. So you might have a sort of gross division. So you might do urban, peat and arable might be one way you could do it. And within urban environments, your target might be to reduce the amount of soil sealing that goes on. So that's covering soils with concrete, tarmac, and allowing those soils so they could be the water could penetrate, and then you'd reduce the potential flood risk in urban areas. And also then there's opportunities for growing vegetation for enhancing urban cooling, for example. Within peats, I think you'd have a target of restoration. So that would be things like removing drains from peats so they're no longer dried, they maintain their wet status so they don't degrade. It would probably also mean taking them out of agriculture, some of them. And then in arable soils, you could develop targets around carbon concentration related to the composition. So within their sand, silt and clay, you can use an algorithm to roughly work out what their optimum carbon content could be. So very quickly, you could use some relatively crude tools, but I think we're all agreed that's where we are, and we don't want anything too complex because then it becomes difficult to implement. But we could quickly develop some targets.
What about overlaying that on catchments? So I get the bit about the diversity of different kinds of soils, and we can have some targets for each of the different kinds and peat, etc. But looking at what Kathy did on the even load in the example she used, and looking at the water citizen science work, the freshwater stuff that Jojo did. Jojo, does it make sense to kind of try to integrate into the catchment what's going on the soils, what's going on the agricultural side, layering on top of the matrix laid down by the classification of the types of soils?
Yes, I think absolutely. I think from a citizen science approach as well, that kind of catchment approach is really great from an engagement perspective in terms of having all the different stakeholders within a community or catchment taking part. And I think in terms of sort of the role as well, what you said about it contributing to target setting. I think it's very much about getting that baseline data, and I think the soils particularly, like there's a huge gap in knowledge. Like Chris said, it's been many years since there was a kind of large scale survey done. So I think that's where I see citizen science being able to contribute significantly to filling that data gap. But with just simple knowledge of simple metrics, nothing particularly complex. But I think with those tools, we can still build up a really good picture of soil health with very straightforward approaches.
And Rosie, National Trust land is in lots of different places, coastal land, etc. But this idea of using the catchment as the basis on which the metrics are collected. The one I know about in National Trust terms is the Honeycutt estate down in on the edge of Exmoor. But does this catchment process, is that a natural way of thinking about things? You've got so much land that if it doesn't work for you guys, it's not going to work maybe elsewhere.
Well, no, the thing is, of course, that we're actually running one program called Riverlands, which is very much catchment based. It's about how you, and that is based both in catchments where we own a lot of land, but also in catchments where we don't, but we're working in partnership with other landowners. And so that's what, I think that's a very effective approach, working with coalitions and using the catchment as a natural kind of management unit. Because then, then water quality in some ways becomes an integrator of all the kind of land management actions or interventions that you're doing in that catchment. So yes, the National Trust is very much taking that sort of catchment approach in some of its programs.
So if in you mentioned this point about tenants, and there is this notion that the National Trust can just command what happens on its land and will jump and do things, but tenants have tenants' rights and all the things that go with that. But if you've got a tenant in a catchment where they're growing intensive maize for, say, AD plants, etc., how do you, as the National Trust, incentivize them to do something which, may be the right thing in particular locations, but it may be exactly the wrong thing in locations? How do you incentivize them to take account of the kind of soil things that Chris has spoken of, some of the water aspects, etc.?
Well, this is actually a very crucial question, and I think the answer is, in many different ways. Part of it is when we actually relet our tenancies. Quite often we have a number of farm business tenancies that run over 1 or 2 decades, which is longer than many farm business tenancies. So in that way, we're trying to select tenants who share our values but are really going to invest in the kind of medium to long term in what they're doing on that land. So it's partly about sharing values. It's partly about working with them and connecting them up with networks like the Nature Friendly Farming Network. We do innovation tours where we actually take farmers around to actually look at innovations that other farmers are doing, because actually, farmers speaking to each other really is the most effective form of communication in this space. We do have a farm in Cambridgeshire, Wimpole, that is actually managed by one of our own members of staff, a farm manager, who is, he's a very good ambassador for farming and for, developing many of these low carbon, nature friendly approaches. But we're also, looking at ways in which we can pilot the natural infrastructure scheme I mentioned in my talk. Doing blends of public and private finance. We want to get our farmers in the best position to take advantage of the new environmental land management system. So, it's many different mechanisms, Dita, that we're exploring at the moment, because I think we do recognise that this is, one of the crucial partnerships that the National Trust, needs to invest in, the partnership with its tenants.
Yeah. And there's the incentive structure around that, including the elms and the carbon prices, and I'll certainly have something to say about that at the end of the session. But just while we're still on this point about this idea of integrating the data together, and I want to bring Kathy back in a second. Melanie, you set out really clearly lots of things, but two things stuck in my mind. The first is that, how much data do we actually have an understanding of what's happening in the marine world? But also this point about the interaction between that and what's going on land. And Chris had that map up, which showed the soil going into the Severn estuary. How do we integrate these two together as opposed to make sure we do both? In other words, how do we get away from the apartheid of marine terrestrial and create a common database so we can see that if a farmer or a landowner does something in the upper catchment of the Thames, that this will actually affect the marine environment down in the Thames estuary, so that we can think about how to optimize across that frame?
Well, I think there's so much in that question, Dieter. It's kind of hard. I mean, in terms of monitoring, we could be getting a better feel for sediment runoff, where the sediment goes and where it accumulates. And we actually have some really good models of that. But people don't believe models unless they see the actual data that, backs up that what the model says, this is where all that flow out of the Severn will end up here, or spread across this area in the marine environment, in the coastal environment. But people don't believe that until they actually have the physical evidence that there's been an accumulation of sediment in those environments, or in places where sediment wouldn't normally accumulate. I mean, actually, the Severn is an example of a place where sediment does accumulate. It's a fairly natural phenomenon. I think it's more where it accumulates naturally, but people think it doesn't accumulate naturally, that we need to sort of be able to demonstrate, well, yes, it does accumulate there. That's normal. I'm not sure I'm explaining that very well. I have a very clear example in my head. But
let me push this slightly further, okay? So when Kemi Baldock was on in the morning's conference, she highlighted 640 million being spent on trees, okay, or the tree program, whatever it is, okay? And you think, gosh, that sounds a lot of money, until you realise that the Bank of England is currently printing another 100 billion, and you think how much HS2 costs, and you add these things together, okay? But let's just say for a moment that there's a political context in which there's so much money to spend on natural capital, and it's a fixed amount. Let's just imagine that for a moment. I mean, I'm sure we'll think it isn't large enough, but that's not my point, okay? So would it be better for me to spend 640 million encouraging landowners to plant trees, in taking Kathy's look at this, in the right places? Or would it be better to spend some or all of that on trying to increase carbon sequestration, for example, helping with kelp or whatever you might identify as the best ways of capturing carbon in the marine? How do we make that advice to government as to where the greatest enhancement benefits come to natural capital as a whole if you've got a fixed sum of money?
Well, I think you hit one of the nails on the head there, which is we don't know because we haven't measured. The seabed, for example, has not been properly mapped around the UK. We're an island state, and yet our guesstimates of what happens where on the seabed is largely modelled. So that's quite an investment to actually go out and actually map what's on the seabed, what's actually there, not what we think is there through models, but what's actually there. To go and visibly model it, to actually look at what the animals are, to think about what the carbon content of the sediments is, to map the coastline of how much salt marsh have we got, how much kelp have we got, how much seagrass have we got, and actually start to get some measure of whether it's increasing or decreasing, and how we could improve those environments that do trap carbon, as well as being the base of the food web, as well as being the base of all the other things that we talked about. But we just don't even have that seabed map. And that's one of the big differences between land and sea, is at least you can stick a satellite up and look at what's on the land and get an idea of the land use coverage, You can send people out, they can look at what types of tree they are and where the trees are. It's a whole different ballgame when you get to the marine environment, and it's a big unknown. So, I couldn't hand on heart say it's definitely going to be better to invest in less destructive fishing practices, in more marine protection, because I don't actually have a map of the seabed. As a marine scientist, I'm pretty sure it would be beneficial to get that map of the seabed and to actually see that there's quite a lot we could do to improve and enhance what we've got there at the moment that might be quite a lot more cost effective than planting lots of trees in different places.
Stunning important point, and that's exactly the point to hand over to Kathy.
Well, I was going to say there's a couple of questions. I don't know if you can read them that are along these lines as well.
I can't see any questions. They're the same three from this morning.
All right. So one of them is basically, first of all, what does optimal mean? What is it? What's best for ecosystem function recovery, or what's the easiest to do given the land ownership? And I think that's and then there's another question that comes in here is, do we need a more inclusive approach to landscape planning that better involves local communities? So it's coming back to this, actually, you can have this top down, this is what we should be doing, but actually we also then need to look at what people on the ground are prepared to do, which I think is the crux of the matter. And I think for me, because one of them says, it's addressed to me, I think the pioneers have demonstrated to us is if you ask everybody an opinion about what they think's best in the environment, you'll come up with 100 different opinions and very little gets moved on. I think we do need to, first of all, provide different scenarios using the science, and then those scenarios being given back to people who are then the land managers to see which those scenarios they're prepared to do, because I think it is how you deliver this is going to be critical. And that goes back to Rosie's point about the tenant farmers. It's actually giving people the knowledge base so then they can effectively make those decisions. But if you take one step further and you're paying people to do things to manage the land, as in the ELM system, then I think the government does have a right to say, actually, we want you to plant trees here because we want to reduce the flooding downstream in this area. So it's never going to be straightforward, this one, but I think it's a mixture of both collaboration with local people and delivery groups, but also having the science to underpin it. And right now we're not very good at that, at joining these two different things together. But there's a question in here, Dieter, also for Jojo. Joe, I'm not sure if are there limits to citizen science being acted upon if official organisations such as the Environment Agency are not doing enough testing and also continue to suffer resource cuts?
I think there's always limits, but I think the advantage I see of the citizen science is, if there's not enough testing going on and if there are resource cuts, I think citizen science actually offers a really good solution for sort of complementing that. It's as I outlined in my presentation, it can really, provide a wealth of data at comparatively low cost. But I think it's only cost efficient if there are win-wins for the citizens and the monitoring agencies. So it's not like we can use the public to collect all this data for free. That's absolutely not the approach that we're saying. But if the engagement from citizens, like with the Blitz we had, where people were really taking part for their own sort of self-interest and action they wanted to take, then I think there's definite win-wins there. And I think it's really about collaboration and co-design, a bit like what you've just outlined, Kathy, as well, about what does optimal mean. I think it's about having that balance, collaboration between citizen science practitioners and sort of fish and monitoring agencies and academics to kind of make the most of that. But obviously there are always limits.
Melanie, you've got your hand up.
Yeah, I think we shouldn't underestimate the public. In the Marine Pioneer, for example, we actually asked them what they wanted from the marine environment. And I think, there is, I'm not quite sure I totally agree with Kathy about the 100 different opinions. Yes, you'll get different opinions, but people do tend to come to a consensus about what's most important. You know, especially if you do limit them and say, well, what are the 5 most important or the 3 most important things you want? So I think there is still a room for that join up between sort of central aspirations or central government aspirations and local stakeholder aspirations. Usually they can converge a bit better than I think you suggested they can. Maybe I'm just a bit more of an optimist.
No, I used to take, I'll just give this example. I used to take the students from conservation students out to a particular coastline of the UK, and it was owned by 3 different agencies. The National Trust, all sections, there's National Trust, the next section up was owned by the Environment Agency, and the next section up was owned by the City Council of that region. One of them was trying to plant pine trees on the sand dunes to encourage the red squirrels. Moved 10 miles down, and what was happening was they were trying to maintain, Natural England were trying to maintain the sand dunes, so they're planting marron grass. You move down 10 miles down the coast, and the City Council wanted people to be able to park on the beach, so they were ploughing up the sand dunes. So in fact, that sand dune natural ecosystem was having 3 completely different management approaches, because 3 different sets of stakeholders had what they wanted as the end outcome was very, very different. And none of those actually, without that connectivity, actually all 3 of those are probably going to be damaging for the nature. So I think we've got to be really careful about, yes, letting people have an opinion what they want, but we also have to let nature have an opinion in here. And quite often nature doesn't get the voice it needs. And so that's where I feel we do need to have a more joined up approach to start with, and then say these are the scenarios. And as you said, it's sort of also restricting those scenarios, but those scenarios need to be underpinned by ecological understanding.
But isn't the answer to that, Kathy, that there are 2 bits that provide that overarching framework? One is the natural capital baseline. You know what the hell you've got in the first place. Yeah. Okay. And the second, isn't that what the targets are supposed to do in the Environment Act? I mean, if there are 10 goals within the 25-year plan, clean air, clean water, etc., right? If we were to have, as we wanted in the committee, statutory targets for all of these, not just for the 4. And to be fair to the government, they haven't ruled out doing the rest in statutory targets. It's just they're starting with the 4. Isn't essentially what the top-down approach is saying, so these are the things that we jointly need to be achieved. They're against the natural capital baseline, and there's a certain amount of money that can be spent. Elms is not a bottomless pit, etc. Okay, and that within that framework, then you try and work out what works on the ground, what's practical, what's deliverable. But in your example of the coastal side, I mean, if your objective is to sequestrate carbon, you plant fast-growing trees that are going to sequestrate carbon. If your objective is red squirrels, then you plant certain sorts of things. If your objective is basically what you were describing in your example is 3 different outcomes people wanted. And my point back to you is, well, isn't that what we're trying to do with the framework of the 25-year plan?
But the difference is the outcomes of the 25-year environment plan are clearly defined outcomes. But if you bring people in and say, actually, what outcome would you like? They may well not align with the outcome you want in the 25-year plan. And that is a tension that we're all dealing with this. And you see it from the questions as well. Who should make that choice as to what nature should look like in a particular area, basically. Yeah.
And that's where, and Ian Bateman made this point repeatedly at the committee, that's where this issue about net biodiversity gain comes in. So Ian would say, if the value of the biodiversity loss is worth an investment of the following amount, let's go and find the optimal place to do that. Whereas the focus on the particular plot and the people who live around the plot biases that. And I didn't mean that in a judgmental way, but just it biases towards delivering compensation very close to the piece of damage that's done. And that kind of tension's there. And I kind of wondered for Jojo, when you were described really extremely clearly the multiple benefits from doing citizen science. So it's not just about the data, it's about engaging people. Do people's views about what they want change when they've engaged in one of your citizen science projects? You said that people come originally, they've got a particular bit of the river that they care about, they don't believe it's properly measured, so they want to participate. Do they ever change their mind and say, well, you know, I've realised it's not quite as bad where I thought it was, but hey, I think we actually instead ought to go upriver and do the following things? Does that ever happen?
I can't think of a specific example off the top of my head where that has happened, but certainly, yeah. People, I would say more so that actually they might think a different approach rather than saying, I'm not going to focus on this bit of river, I'll focus on this bit of river. So they might just become engaged with the idea. For example, we've been trialling coppice bundles with farmers as a kind of nature-based solution to preventing soil erosion, and we've had several farmers that have started doing that, having had no sort of engagement or experience, and have now gone on to kind of take the lead and go, I'm really interested in doing this, and they're now trialling different things on their own that has nothing to do with the project that we started. So I think more that sort of thing that I've seen, rather than going, oh, there's not an issue here, I'm going to focus over there.
Yeah, that's really helpful. Rosie, you want to come in, and I wanted to ask you a question, which is that we have a 25-year plan, and we have these, we're going to have these targets within it. But you as the National Trust have your own charitable objectives and your own views about how that's done. I'm sure your members have lots of views. How do you prioritise? And will the 25-year plan goals and targets make any difference to the priorities you would have chosen anyway?
Well, certainly those 25-year environment plan targets will make a difference. But, you know, in some senses that you know, they are the ones that the science would suggest that you aim for. So in that sense, I would hope that we're all pointing in the same direction. But I think also, yes, in terms the National Trust is actually quite a devolved organisation. So what we anticipate doing, you know, I work at the centre, we create, you know, tools and guidance, and then we aim to work with those properties where there are the biggest opportunities, engage with the people who are managing those properties, the estate managers, you know, the local landowners and tenants, to actually try and make the most of those opportunities. So, you know, it is very much a blend. We aim to have a blend of a top-down versus a bottom-up approach.
Yeah.
Now, the reason why I put my hand up there was to partly to sort of supplement what Jojo was saying about citizen science, and you were asking her really about biases. I mean, that is one of the problems with citizen science data. It is kind of messy data. It will have biases, but actually the statistical techniques that have been developed in citizen science organizations have really, you know, taken strides ahead over the last 5 years, and they can model those biases and therefore extract much greater information from that kind of citizen science approach than we have been able to previously. So, you know, it really has enhanced it as a genuine provider of scientific information.
That's very helpful. And just one final thing to Jojo again. Sorry to keep picking on you. The urban side of the citizen science, you know, things like the backyard biodiversity and so on. And how big a picture is that picking up? And do you get more engagement in looking at urban areas and the possible natural capital benefits there, as opposed to wider rural and countryside approaches?
I think we use very different approaches. So the kind of 4 approaches that I outlined, citizen science, I think with the urban stakeholders, we've been using a much more sort of community based participation rather than the kind of mass approach or the sort of one-on-one. We're using that community approach. So we have Naturehood, which is trying to find urban communities in cities to sort of come together to enhance wildlife in urban areas, for example. So yeah, that's the kind of approach we've taken in cities, and it's been more about again, it's the sort of action you want them to take. So I think with that as well, it's more about awareness raising and then engagement. Whereas I think with the sort of rural stakeholders and farmers. It's more about kind of empowering them to sort of take leadership on it, if that makes sense. But also with the community aspect, coming together different farmers. But yeah, we do have a lot of interest, but it's a different kind of audience. It's more sort of focused on kind of families and activities that would be engaging to children. And that's the kind of citizen science approach we've taken in rural, urban areas. Just to jump on what Rosie said as well, very briefly, about bias, I think one challenge we have is the engagement bias. I think have a group of people that it's very easy to engage, and so it's quite easy to assume that that's the feeling of the nation or the community, and actually it's really, really hard to reach communities, and that's quite a big part of the work we're doing in urban areas, is trying to reach those hard to reach communities.
Yeah, thank you very much indeed. And that's run out of time on our Q&A, and I'm sure there are lots of questions we haven't properly addressed, but we picked up lots of themes, and thank you very much to all our speakers, and thank you for engaging so fully in the Q&A. Kathy asked me, this was supposed to be Kathy's show in the afternoon on the science, and we've had science all the way through, but Kathy asked me at the end to whether it was possible to try to bring together the science with economics and to make some suggestions about how this all plays out in policy, ELMs, carbon markets, and so on. So let me use a little bit of time to set out some of the ways in which these things come together, and then I'll wrap up the session on time, as I always do. So when we set up the Natural Capital Committee, one of the really difficult issues at the start was this going to be science? Was this going to be basically economics, treasury driven? Or was it going to try and combine the two? And it was very clear that what we were going to do is have scientists and economists together and try to make that work. And that, I thought, would be our downfall, and that, I thought, would be the thing that I would find impossible to chair. That 8-9 years ago, multidisciplinary approaches to these problems were notable for their absence. And what we did was deliberately graft those things together. So in the first Natural Capital Committee, Rosie, Georgina Mace, Colin Mayer, and Ian Bateman in particular welded together the two approaches. And that's one of the great successes of the Natural Capital Committee, that we actually have produced an integrated science and economic approach. We've shown what the science requires, what it tells us, what we need to do, and it's also told us how to think about allocating the scarce resources that are available for natural capital and how to get the best economic benefits. And let me just sketch out how this works. So economists seem to assume that when they don't know something, well, we just assume it and get on with it anyway. What we've done in the Natural Capital Committee is we've put together the toolkit. And we've heard this afternoon that it's very incomplete, but we know what the toolkit has to contain. We know what the census should do. We know what the natural capital assets are we need to map, and we know the domains over which we need to do that mapping, onshore, offshore, the various dimensions. We know that. And we know that we have digital technologies, a whole host of IT that enables us to refine that better and better. We will crack Chris's problem, we will crack Melanie's problem, and we will be able to put this together in a framework. And that is, in the short run, provided the Treasury comes up with the money to pay for the baseline. And Kemi Baldock this morning pointed out that money had been found for a pilot, but as a Natural Capital Committee, our advice is you need to do the whole thing, do it properly, and get on with it, and get on it really quickly so you know what you're doing. And that includes the citizen science and the components to that. If Dudley Stamp can do it with what he had available to it, there is no reason why we can't do it, and the benefits from doing that will be great. Now, why do we want to know what the baseline natural capital is? Well, at one level, we want to know whether it's getting better in aggregate. And that's because the goal is to leave more natural capital, better natural capital to the next generation. It's not, as economists typically think about this, that we want to make sure the next generation's happy, that they have as much utility as we do. Most economists, if you scratch them deeply enough, are utilitarians. I've never bought that argument. I think what we're doing is saying the next generation should inherit a set of natural capital better than we have, so that they can choose how to use that natural capital and how to use their lives. It's beyond our knowledge to be able to predict the happiness or utility that come from it, but every kid should have access to green space. Every citizen should have access to clean air, clean water, and then in the framework of that infrastructure, they can decide how they want to take things forward. And the two bits that then come into it, and this is what Colin Mayer has brought to us, is, well, if you want to do that, you've got to split it into two bits. First of all, you've got to identify the capital maintenance necessary to ensure that this natural capital does not depreciate. And that's essentially renewable natural capital in the economist terms. And what does that mean? Well, most accounting, most farm accounts depreciates the tractors, depreciates the buildings, etc. But natural capital can't be depreciated. It's assets in perpetuity. So you don't have depreciation, you have capital maintenance. That amount of money to fill the holes in the road to make sure the roads continue to function as roads. And that's exactly what we want to do across into the natural environment. Now that has a very, very radical consequence. If the job of the state ultimately is through the public and private sector to maintain that natural capital through time, the first charge of the revenue account of the government ought to be capital maintenance. And when the Chancellor stands up and announces the most humongous deficit we've ever known, and then the one after that that's even bigger, this should be net of the capital maintenance. And by the way, for the energy system, for the water system, for the railway system, for the road system, etc., for all the infrastructures, we want to make sure that that's done. That radically transforms our view about where the economy is and what the state of the economy is, and whether we in our current generation are living beyond our environmental means or not, whether we're paying our dues to make sure that goes into the next generation. Then we want to find the enhancements. Okay, now what we had in the example that Kathy put up, in some of the examples that Rosie had and earlier during the course of the day, were lots of great ideas. There is no dearth of ideas for things we could do to make our natural capital better. Melanie had a whole suite of things that we ought to be doing. And I'm sure that others have those too. The problem that an economist brings to this, or the skill that an economist brings to that, is to say there isn't an infinite sum of money. That's why we are the dismal science. We can't give everybody a Christmas present. And given that that's the state of the world we find ourselves in, given the amount of money that's available, say there's 3 billion for agricultural subsidies, how can we spend that money to get the greatest environmental bucks in natural capital terms to best make sure we do the job of making sure those assets are passed on to the next generation enhanced? And that's where the tools of economics become very useful. If you spend money on X, you haven't got it available to Y, to spend it on Y. That's why I asked Melanie the question, well, would it have been better to spend the money in the marine area if we care about carbon, or better to spend it in planting trees at the top of a river catchment or putting the carbon back in the soils? These are choices. And at the moment, they're not choices that are made with a view to maximising the environmental benefits of totality. They're based on the grounds of bias, what citizens groups might say they want. They're based, let's be honest, on ignorance quite often. We just don't know what we're doing in certain circumstances. And that's why getting this science right enhances our ability to make those choices. Now that opens up the policy box. And that's where scientists and economists should be engaged. You see in the coronavirus briefings, science, we've got to listen to the science. There are no economists in that discussion. I would never want to just listen to the economists. But when you make public policy choices, whether they be about lockdowns or they be about whether to plant trees, you do have to have some policy framework to do that. And broadly, there are two options out there, or philosophies. There is the one which says, you know what we want is to get some good regulators to go round each farm, each particular asset, and tell people what to do. And I'm sure, as Chris stressed, that by enhancing the regulation, we can take that forward. We could go around and tell people not to plant maize on the catchment around the Somerset levels, full stop. We could say that just doesn't meet the compliance. But there is an alternative way of doing this, which actually I think will be complementary in the end, which is say, let's turn it around the other way. Let's ask people what they can offer. Let's ask people to bid the improvements they can make. So take a catchment, take the even load, or take the Thames as a whole. We could ask farmers, you know, there is this pot of ELMS money, there is this pot of agricultural subsidy, you bid, you tell us what you can bring. And by the way, if you bring better benefits by doing it on a systems basis and cooperating with other farmers, you're more likely to be successful. And that is an opportunity which is bottom up to ask people how best they can contribute to the goals within the 25-year plan. And I think that's got a lot of mileage in it. And the place it's really got mileage is in carbon. The thing about carbon is it doesn't matter where the carbon is emitted, and it doesn't actually matter where it's sequestered from the point of view of carbon. It matters for all sorts of other stuff, but not for the carbon itself. Okay? So we have a price of carbon. It's the EU ETS price at the moment. And by the way, on the 1st of January, we'll be out of the EU ETS, and there's a consultation paper from the Treasury on how we should price carbon in the post-Brexit transition world, carbon tax, emissions trading scheme, or whatever. Now, the important point is that if you have a common price of carbon, we should start thinking about applying that to sequestration, to the natural environment, paying people to sequester carbon. And then people can bid and say, you know what, I can do this number of tons and I can do it at the price you've got available in the market because I can do it really cheaply and someone else will do it more expensively. And that's a great opportunity. It's just one part to bring the natural environment sequestration side into the same framework as the emission side, which is going to be priced. And by the way, that means pricing carbon from farms as well, etc., which is slightly less politically easy. So you can do that. But of course, there are people who already do the right thing. They already sequestrate the carbon extremely well. And that's where the ELM scheme comes in, because that's essentially about keeping good practice. And that will have to be done on a farm by farm basis. Now, I say those things not because they're a comprehensive set of policy frames, but I want to go from the science to the accounting to the policy, all with the overall objective, which has dominated everything we've been doing in the Natural Capital Committee for the last 8 years, which is we have to leave the natural environment assets in a better state than we inherited them. That's the job laid down in policy. And frankly, as we demonstrated in our recent assessment of the second progress report from the government, we're not even holding the line. And that is really serious. We are 8 years in, or 9 years in, because 2011 was when this objective was set, and we're going backwards. There have been lots of successes, but the overall picture is not good. And so my passing message from the Natural Capital Committee at the end of this conference is to policymakers, to ministers, to civil servants, to everybody involved in this space, private, public sector, NGOs. Get on with it. The opportunities are enormous. This is good for the economy. It's damn good economics. It's very good science. The accounting framework is the right way to do this. What's not to like about what we've recommended? Why not just do it? And that's my passing shot. And we've run out of time. So it remains for me to thank you all for listening in and for your tolerance of the odd technical glitch we've had during the day, but we've basically kept to path, and particularly dealing with my incompetence technically as we've gone through. But I hope it's been useful. I hope it'll encourage you to go back and read our documents, look at what we've done, and I hope it'll encourage you to build on our legacy. And then finally, thanks to all the members of the committee the first committee and the second committee. Thanks to the Secretariat, and thanks to Jojo for joining us too, and Rosie coming back from the first phase to this session. So thank you all very much. It's been a privilege to chair this committee, and I hope that we provided a good framework to make that pledge to the next generation delivered and deliverable. And as I say, let's just get on with it. Thank you very much.
Thank you. Thank you, Dieter.